So it's time to move to our second presenter with a little bit of delay. I'm sorry about that. But we are very happy to have Chiara Sotis with us. I hope I pronounced her name well. Chiara is a very young and bright researcher. She's actually doing her PhD at the London School of Economics, not the worst university in the world, while she also is teaching fellow. So she's also teaching microeconomics, and she's interested in broad range of research, environmental economics, game theory, through microeconomics, finance. So she really has a wide range, including data visualization, which is something that we don't see so often in economics. So she now focuses on the role of information and social, what the role of information and social learning play in determining behavior and how this behavior change over time, which is a very, very difficult topic. And very recently with Alessandro Romano, Goran Dominioni, and Sebastian Giudi from Yale University, she wrote a very interesting paper on how the scale of COVID-19 graphics affect understanding attitudes and policy preferences. An extremely important topic when one realizes how popular these graphics were and how they have influenced the public debates in the UK and also the political decisions. So without further ado, she will present this paper and this question much better than me. So thank you, Chiara, for being with us to talk about that. The floor is yours, let's say for 45, 15 minutes, if it's okay with you.
No, thank you, and thank you all for sharing part of your Friday evening with me. I think this has been a fairly comprehensive session already. I'm very thankful to be part of it as my co-authors. Sandro Romano, who I think is on the call, is from Bocconi. He was in Yale Law School when we were doing the paper. And Goran Dominioni and Sebastian Guidi, both from a law background. Goran is in Dublin now, and Sebastian is still in Yale Law School. Right, so let me start with an apology, both for the technical issues, but mostly because my graphics will never top the ones that you've seen so far. I don't come from a data visualization background. I come from a purely economics background, and so really it's just kind of a different game in here. But what I wanted to do is still give you a bit of an overview. As you can tell, these are not incredibly sophisticated icons. We've done worse in the paper. I'll tell you more about this later. But what I wanted to do, because this is more of a why does data visualization matter paper rather than how do you do good data visualization, I wanted to motivate it to you, and I'll hopefully show you very cool graphics that weren't done by me, and so they're great. And then I'll tell you why it mattered in our experiment. So let me start by introducing the idea of the paper. We know that the pandemic has fostered people's interest in data and news. In fact, the news has seen an exponential growth in consumption they hadn't seen before. And this is due to many things, right? There's new information about the virus that comes all the time. I think, for instance, about the new strain of virus in the UK. There's new government guidance. Italians have been stuck in front of their TVs for so long now because our prime minister needs to announce what happens over Christmas in terms of restrictions. And so I know that my mom is compulsively clicking on, on her TV and trying to find out what's going on. But also we want to hear from other countries. We want to know about the vaccine. We want to know about the number of cases and deaths. And especially, you know, we had this idea back in April, and this was still the first wave all around the world. We wanted to know just how severe this problem was. And I think we all underestimated it to some extent. So really everyone's routinely searching for this. And what I want to show you is that this doesn't mean that it's only educated people, that it's only rich people, that it's only people who lost their jobs. It's very diffuse. And really for the first time, I found this piece of news and I thought I'd share it. Printed newspapers, which were seeing a drop in consumption pretty much all over the world, saw a rise again. And this is interesting to me because, you know, you need to disinfect your hands so many times if you're getting one of these, but you know, it's showing us just how much people want to know more about what's going on. But of course, what matters isn't just how much news people consume, but rather also what they understand from what they read. I could read an engineering paper. That doesn't really mean that I'm going to get away quite a lot from it. I could read an econ paper and most likely, you know, ideas will click a little bit better. And of course, how much you understand and what you read is likely to shape your opinion and in turn to influence your behaviors. And because we know that so much before the vaccine was rolled out depended on people's behavior, this is pretty important here. So what I wanted to show you is cool infographics. You can find them online, it's great. So this is just a report on how much people increased their activities during the lockdown and during quarantine. And this is all over the world, so it's not really looking at one country in particular. Of course, if we looked at, the increase, the first one is searching for coronavirus or COVID-19 updates. That's not surprising. We didn't have a pandemic before. But also they're just increasing the idea of technology entering into their lives. And this is not by generation, right? We see an increase in PC gaming and watching news and watching TV. This is something that we can all relate to, especially in education. What I didn't realize is that it really doesn't depend on the generation. This increase in news consumption, be it online videos or written newspapers, this is going to vary a little bit by age if we look at the graphics in here, but not the amount of news that people are consuming. This is increasing all across. And so, you've already done this poll, and I'm actually quite thankful that I'm presenting now because I get to show you your results. But the idea of these graphs is really, these are overview graphs. I think two of them are really a giveaway. You can see the pink background and it's the Financial Times. Part C is kind of the evolution of the one that we've all seen at some point with the log scale. It's now in linear scale. We'll talk more about that too. The other part is more recent, thinking about total excess deaths, and this is more a measure of severity of what's going on with the virus. Part A, this is the official information from the WHO. It can be linearized as well, so that instead of showing you each point as a bar, you can see it as a trend evolving over time. You can also see it daily or weekly if you want to get a sense of, we all know there are inconsistencies in testing on Sundays, for instance, and so it might be more informative that way. And they also give you the total cases. They're just trying to build, a good picture of what's happening around the world. What you see in part B is actually from The Guardian, what they're doing. It's both on The Guardian UK and on this website called Coronavirus Tracker. And what they're trying to show is new cases and new deaths at the same time, but you can see that the deaths are quite small, and so you may not really get a sense of what's going on. And this last one in here, this is also from Coronavirus Tracker. This is the first plot, part D, that you can see in Bing, which is, the search engine we no longer use, but still gives us news whether we want it or not. So I'm going to apologize to Jan before I turn to the next slide because it's a pie chart, but I promise it's just because Google Forms gives you automatically responses from here. This is the graph that you guys found the most informative. As you can see, there are two in there. One, these are both cross-country comparisons, so you thought there was value in seeing more than just my country or my cases. The first one is the one that the WHO is producing, which is, I think, good news, right? It's telling us that the World Health Organization actually knows how to inform us. The second one is the Financial Times one. I quite like the use of colors in that one, and it gives proportion quite neatly. Also very hard to make graph. But when I go to the second poll, when we thought about, okay, but what would you use in a newspaper aimed at a general audience? Big result in here, we're flipping it entirely. We think that the excess deaths per million of people are much more informative. And I think epidemiology would sort of agree with you that this is what we want to show. This gives a sense of the severity. We didn't quite start from these ideas when we started thinking about the paper. What we started from, though, is the idea that the same news could be conveyed in different ways. And looking at graphs from a behavioral perspective really tells you something different. Right? So if I look at the first two graphs up there, what we have is the Washington Post and Vox, and they're using a linear scale to depict the graphs. And what that means is that each bar corresponds to the same increase in the cases, right? So if you look at the second one, this is probably clear. What it's doing is each bar represents 100,000 cases, and it doesn't change all throughout. If we looked at what the New York Times had and the Guardian at some point, the Guardian has a variety of graphs right now, so it's not quite as sure as it was back then. They used to have log scale graphs, so each bar in the graph is actually measuring a different increase, and the same distance on the y-axis will go from 0 to 10,000, and then from 10,000 to 1 million. And what we wondered is whether looking at these graphs might give you a different idea of what's going on, right? So if you look at just one of them, Do you get a different sense of how this pandemic is evolving? And does that influence in turn what you're doing with your life? Are you going out more? Are you supporting more policies or less policies that give back? And I found this quote, which is actually from after our paper was published, from Bert Marnott, which is the guy responsible for the Financial Times graphs. And he said, without data, it would be very easy for governments or for the media or other people with vested interests to just tell their own story about how things were going. And there'd be very little that anyone could do to push back on it. And this is so interesting to me because it's true. If we didn't have any information, we really couldn't decide what to do, right? We would need to rely on some sort of information. But the thing is that even if you do have information, it's not obvious that you know how to read it. And if you get a different impression by looking at different graphs, then maybe you react differently as well. So this is sort of what we wanted to test. But before we get there, what I wanted to say, and I think this is important because we'll claim that log-scale graphs are not that great. Some journals and some outlets actually chose them for very specific reasons. The Financial Times was there arguing the same exact things that the New York Times is doing here. And they're telling you, well, log-scale graphs are good because they emphasize the rate of change. And linear scale graphs don't do that, right? At some point, you just explode. Unconstrained, the coronavirus spreads exponentially, and the caseload just seems to be doubling at a steady rate. But that curve plotted linearly is a skyrocketing curve. If you plot it logarithmically, it transforms into a straight line. And then you can really look at the deviations from the exponential spread, and you can really tell them apart. So the idea was, well, you know, people are good at reading these graphs. And if we want to take a look at how much this is growing, how diffusion is working for the virus, then actually this is a much better way of looking at it. And this is not without foundation. Some epidemiology journals were suggesting the same, some data visualization handbooks were doing the same, and they just tell you, you know, this is really based on the pandemics at the beginning of the 1900s, but they're telling you if you want to see growth, then linear scale is not how you do it. But do people understand it? So I really like this short paper from Garfin, Silver, and Holman. This came out a month before we were working on ours. And they note that during a public health crisis, not only the consumption of news is going up, but really the general public is relying more and more on the media to convey accurate and understandable information. And these words really mean a lot here, right? Because if we want to make informed decisions, then you need to be informed. This is quite straightforward, but how do you inform people? How do you make them understand what is going on without biasing them one way or another? And really, the other side of this coin is if the public is provided with data, but they don't understand it, when they're making decisions to comply with lockdowns or to support government policies, say redistribution of income, for instance, or in our experiment, distribution of government masks, are they making a choice that they would support later on? Could they end up regretting their decisions just because they didn't quite figure out what was going on? And well, this is not coming out of nowhere. There's actually plenty of evidence that people don't understand log-scale graphs that well. So previous literature has shown us that log scales are pretty hard for people to understand. And what I want to show you is actually it's not just people, it's even very technical people. So the picture on the left is taken from a paper by Heckler and Arp from 2013. And what they're finding is that the majority of university sophomore, junior, and senior engineering students, right, these guys do a lot of maths. In a material science course, they were doing this for credit, so very high incentives to get it right. They didn't. Looking at questions like this, where they were taking a look at the number that was between the segment and the line, they were supposed to guess the right answer. And actually what they did is interpret it as a linear scale, right? So you would think, well, it's between 10 to the 8th and 10 to the 9th. It must be 10 to the 8.5 or something like this, which is not the answer. And this is not only true for engineering students. Menge et al. In 2018, this is a Nature paper. They surveyed members of the Ecological Society of America, and they found very similar results. Many respondents were interpreting the graphs correctly when they had linear axis, so just kind of straight down x, y. At least one of the axes was in log scale, even though 69% of the respondents had PhD, so highly not representative sample here, they got it wrong. And what they were suggesting is, given the frequency of these incorrect responses and this regularity in which they are exposed to logarithms, they suspect that this confusion is common among many scientists, not just ecologists. And to ask what that meant is, well, if these guys that are at the very top, they see logarithms all the time, they see data all the time, and they're getting it wrong, think about the general population, right? And so what we wanted to do is really test this idea. You look at different graphs and the impression that you get is completely different, and that can affect your decisions on other dimensions as well. So what we did is devise a double-blind online experiment. It sounds very fancy, but what we mean is people don't know the treatment they will be assigned to. On Cloud Research, this is a spin-off of MTurk, for those of you who have done experiments before. And we had approximately 2,000 people participating. Generic exclusion criteria: they had to be at least 18 years old, they had to give consent, and we wanted US residents so that we could sort of target people that were in the same boat, or at least had some similar sets of information. And then what we do is half of the participants are randomly assigned to a linear group in which they see the evolution of COVID-19 deaths in the US on a linear scale, and half of them to the log group, where they do exactly the same but on a logarithmic scale. And the graphs are taken from worldometers.info, and I kind of want to show you what we did with them. If you were part of our experiment, you would have been assigned to either the graph on the left with the description below, or the graph on the right with the description below. The description didn't have any highlighting, so what I'm doing there is just showing you that the framing is exactly the same, except for telling you that the graph you're about to see is on a linear scale. So if I go to the left, what we're telling them is a straight line means linear growth, and the steeper or more convex means the faster the number of deaths is growing. If we go to the right, same thing, but you're seeing it on a logarithmic scale, and so we're telling you that the steeper the line, the faster the number of deaths are growing. It's not quite a long explanation, but it's very similar to what you would find on the average website or on a newspaper. And what I want to show you is also that the sample that we're looking at is quite balanced, which doesn't happen that often in online experiments. I was a bit surprised by this. If you want to read this table very quickly, what you're looking for is the fact that there are no stars. If there were any significant differences between the compositions of the groups, you would see them. If you want to step in a little bit more onto what's going on, the majority of our sample is between 26 and 55, but we have quite a lot of people at the two tails. Quite a lot of people that have some college or some associate or bachelor degree. In fact, the median has a bachelor at least. Few people with a PhD, definitely not the same sample as in Nature, right? Quite a few people stopped much before that. Same thing we see on income, and if I move on, same type of political orientation as well, balanced across gender, balanced across living in a big or a small city. So we didn't think it was anything to be worried about, is what I'm trying to convey to you. After all of this, what do we think about? Well, three main things that we want to know from these people. First thing that you would do is give your consent, and then you would be shown the graph without any sort of priming. We're not telling you how to read it, what to do with it. And then we ask you about determinants of worry. I'll show you the results for all of these in a second. We think about policy preferences, and we think about understanding questions. We kind of wanted the understanding questions to be at the end, because otherwise you're really primed. If you're looking at a website or a newspaper article, you wouldn't be asked, oh, what happens in a week from now if the trend keeps going at this rate, or any understanding questions. You would just rely on looking at the graph and then looking at what the article is saying. What we did want to do is, it's unrealistic to ask all of these questions without showing the graph again. So after being asked about their level of worry and their policy preferences, people get to see the graph once again before answering these understanding questions. And at the end, we collect standard demographics, which are kind of the ones you've seen in the balance table so far. So what do we find? Well, when we think about worry, we wanted to think about worry about the health crisis generated by the COVID-19 pandemic, and we wanted to think about the worry about the economic crisis generated by it. And what we find is that there's no difference between these participants in terms of how worried they are about the economic crisis. They might be now if they were to see them again, because the curves have changed quite a lot. But what the scale does affect is people's level of worry for the health crisis. Whenever people see the linear scale plots, so this growth that seems steeper really, they get more worried about the health crisis, regardless of their understanding. So what we're doing in here, I'm not showing you the full results or it would be illegible, but they are in the paper, is we control for their understanding of these graphs through our questions. And this is just a simple effect of looking at linear scale graphs. Now we do the same for policy preferences, and let's define what these policy preferences are for us. It took us a very long time to think about this because in the literature in April, most of the questions were about, are you willing to wash your hands more frequently? Are you willing to disinfect something? And we wanted something that had a bit more impact on society, really. So we thought about support for closing non-essential businesses, and we tell respondents that essential businesses are defined to be supermarkets and pharmacies, all the ones that are staying open, until when they would keep these businesses closed, and how often they would use a mask if the government sent a supply to them, and finally, whether they would support a tax that finances the distribution of masks from the government for everyone in their state. So, you can think about the fourth one as a preference for redistribution. The rest affect both individuals and society. If we take a look at what's going on, what we find is that people in the linear group prefer to have non-essential businesses closed for longer. So again, they think that this is going on for a while, but they support less strongly the idea of closing them in the first place. And our assumption behind this is that if you keep seeing it grow, maybe you don't think it's reached a peak just yet. And if you close now, you're going to have to keep it closed for quite a long time. Maybe we wait until it gets worse and then we really close it. And curiously enough, governments have done this after this paper came out. If we think about wearing masks and supporting tax to buy them, people in the linear group would wear masks more often, and they support more strongly government provision. And I should note that, again, here we're controlling for understanding. We're also controlling for the political affiliation of the participants, and you kind of get what you'd expect with Democrats supporting more highly taxes to redistribute masks and Republicans supporting it less. And finally, block 3, so we're thinking about the understanding questions. We have 3 measures of understanding, and these are not incredibly comprehensive. There's a lot of doubt around what it means to understand a graph, right? But we thought these are things that are likely to shape how people behave. And so we thought it was important to get a sense over these. The first one is whether you can understand what's going on. So we asked people whether deaths have increased more between a week or another. And remember, they have the graphs to look at in front of them. Second question is we show them a graph describing a completely unrelated question. These are data that are made up, but we took them from an existing paper. And we asked them a similar question. So you're still seeing a graph, but this time it's not COVID-19. So you can't have heard anything on the news about it. You can't have read about what is going on, what experts think will be going on. You just need to rely on the graph in front of you. And finally, and 3 is really the hard question. We test whether people can make a prediction based on the curve. And so can you give us the best estimate for the total number of deaths a week after we launched the experiment? And on this third one, we kind of needed to think about a benchmark, because if you think about forecasting, what are we comparing it to? And so what we did is use an ARIMA model, and we simulated it to find the best parameters. So we're finding a 0 to 1 as the best fit for our data. And this has been used before in COVID predictions. This is not a super sophisticated model. R will do it for you. Stata will not, but Python will, and give you a bunch of simulations if you want them. What we're doing is relying on the confidence interval in here. So the 95% confidence interval and the 99% confidence interval. And what we're doing is saying, well, first of all, I can now say it's quite an accurate prediction. The actual number of deaths on the day was 54,256, and our UMAT predicted 55,000, so it was a bit higher, but not that much. But secondly, what we wanted is for people to be in a good range. We didn't want the exact number. That's an incredibly hard thing to do. But we say, well, if you fall within the 95% confidence interval, and this is fairly large, it goes from 49,000 to 62,000, we deem your prediction to be accurate. If you are outside that, but within the 99%, so larger interval that you're considering, then we deem it unlikely, but it's still possible. If outside this interval, then we deem it unreasonable. and we had some predictions at something like 150,000. So it was, some were really unreasonable. So what do? We compare what happens. And these are, again, not the best data visualization tools. These are graphs that come from data. What we wanted to look at is whether people in the log scale or in the linear scale would get more correct answers. And what we see is that linear scale people tend to get it right. More than 80% of people tend to get it right. Only 40%, 41% of people get it right in log scale. And once we go to this infection Z question, so remember on this, they had no external information whatsoever, and they had to rely on the graph, then it's even starker. 85% of the log scale people didn't get it right, and 87% of the linear scale people got it right. So quite a stark comparison in here. And this is not sort of the interesting part. We expected these results, but it's good to confirm that, in fact, people don't tend to get it that well. When we think about understanding questions in terms of forecasts, we're using two different ways to look at it. We're thinking about the ones that have made an accurate prediction on the panel on the left, and we see that only about 30% of the log scale group did. Around 41% of the linear scale did. So, it's still very hard to make an accurate prediction, but not only the linear scale gets more accurate predictions, they get less unreasonable ones. So in a way, it's just telling us it's a bit easier when you're looking at something grow and you can pinpoint it on the y-axis. What effects do we see on all of this? Well, these are in odds ratio terms. So for those of you who are not familiar with it, the line in linear group tells us the difference between being in the linear group and in the log group. And what it's telling us, I'll start from sort of the stark one. If we go to understanding question 2, the hypothetical one, this is the infection Z question, 123.9 tells us that people in the linear group got it right 123 more times than the people in the log group, which is incredibly high. And if we think about real data, these are a bit more biased. People are likely to have heard some information about it, but it's still 8 times higher in the linear group. It's so much easier to get it right. So much harder to get an unreasonable prediction. That is why we get 0.6, so only 61% get it. And it's much higher worry about the health crisis, higher support for a tax that buys masks for people. It's something that really affects the way that they interact with this virus, right? This is not just about how people understand the data in front of them, but how do they use them to make decisions. And so this is our hypothesis for what's driving the results. And we're not claiming that this is the only mechanism, but we're telling you, merely changing the scale. So really, this is not even data visualization at a high level. It's not about colors and different plots. This is the same exact plots, same colors, same website. The only thing that's changing is the scale, and it's already altering people's policy preferences, their level of worry. And this is in a case where people are reading quite a lot of news. There's a lot of information to which everyone is exposed. We cannot be sure about the mechanism, but what I can tell you is that these are robust to a number of controls and specifications. So if you take out the understanding questions, for instance, or if you're analyzing them through a logic model or an ordered probit model or an OLS, these are staying there. And our hypothesis is that it's really about the shape of these curves. If you're taking a look at something that keeps growing, you believe that this will go on forever. If you look at a flatter logarithmic curve, you might think that we reached a plateau or that we're about to reach it. So things are getting better over time. What do we think are the main takeaways from this, regardless of the reasons that are driving these results? The fact that changing the scale of a graph can alter policy preferences tells us that data availability isn't quite enough. We need people to be able to engage with this data. The way you present it will have impacts on what people do. And this is, intentions to adopt precautionary measures affect the rest of the people around you. So these are quite important effects. And what we want to convey is that really, if you give unclear information to people, the risk is that all the measures that you're implementing as a government will not be effective because they just don't know what's going on, or they might, underestimate the severity of what's going on. Mostly, it prevents people from making informed decisions. So we don't know whether these are their real preferences. We're not saying that people should be more worried or that they should support taxes more, but it's really hard to say that you're making exactly the decision you would want if you're making it without understanding what you're seeing. So we're not saying that linear scale graphs are the only ones that you should use. Although, you know, quite a lot of websites have now changed to linear scale graphs. And in fact, that graph that I've used from the Financial Times is quite old. They now have the much neater ones that we've seen at the beginning. But using linear scale graphs does help people understand the data better. And so if you want to convey messages to a general audience, make it easy, make it understandable, and at least people will make decisions based on what they understood. And this is sort of my 2 cents. I think looking forward, what I want to conclude by is that this has mattered quite a lot in the pandemic, and I'm sure if we reran it now, we would get slightly different results, or at least, you know, we'd be able to check more things. But this is a general lesson in data visualization. What you do is not just important because it will look cooler on a screen, although some of the visualizations do look much cooler on a screen, but because it has real consequences on real people. So I want to thank you for spending quite a lot of your Friday with us. If you have any questions, comments, or feedback, I'm super happy to take them now. I'm actually quite on time, which is pretty good. And if not, feel free to email me. I'm going to stop sharing the screen now as well, so I can see the chat.
Thank you, Chiara. It was a very, very interesting presentation, very clear, and thank you for making this clear for everybody. And we have one or two questions here, but I will take the lead on one because there are two questions actually I want to ask you. The first one is maybe obvious, but it's likely that many politicians also were looking at these graphics and they were having an intuition of what will happen based on these graphics. And so is it possible that these graphics have had an influence on the political decision that because politicians are readers like you, if PhD students cannot disentangle the things, is all the people, all the category of people you had in your sample were also having this misinterpretation. It's really a big concern, right?
Yeah, so I think this comes from the fact that, you know, we require politicians to be technical on some knowledge, but not all the possible knowledge, right? And so even when we think about health ministers, they don't often come from an epidemiology background or even just a medical background. So that's definitely plausible. I think at national level, this is slightly less true. Most of the governments had technical committees that were advising them. Presumably, these guys are a bit better at conveying this information, or at least could interpret it better for the governments. But especially at local levels, if we're thinking about a governor or mayor, it's very likely that I look at these graphs and I interpret them the way I want. And it's also really hard not to do it. So I'll give you this anecdote. Both my parents are doctors. And when they were looking at the same graphs, right, same scale, same graph, same outlet, same education, they went to university in the same years, it doesn't get better than that. They really thought different things about how it was going to go. Now, my mom is really risk averse, and so you could make a point that she was more pessimistic because of that, but their forecasts were completely different. Their precautionary measures, which I think is what matters a bit more at policy levels, right? You keep people at home or you send them to work. What are you going to do about transport and all of these things? They were very similar on that. But in terms of how this is going to evolve over time, even within that same background, there were differences. So I think that's even more true when you don't even have that background.
And the second question is, the graphic you showed, there was a piece of information below the graphic explaining how the graphic is made, but there was nothing on the graphic, unlike what the Financial Times did by putting a straight line on a log scale saying, on this line it's doubling, on this line it's doubling in 2 weeks, on 4 weeks, or on 2 days. So do you think this might have changed the perception? Because the Financial Times puts, and this is also what Alberto Cairo was saying, Edith was saying, and Jan was saying, annotation layer on this on this graphic. Do you think this dramatically would change your results?
I think so that there are two separate points to be made. One goes to the people who made the graphics, and I think the Financial Times did a brilliant job. The New York Times is doing the same, looking at forecasting and how it would look like and doing all the simulations. The issue is how much attention are people paying to this? So if I stop and play around with this graphic and take my time to engage, then the fact that there are different lines in different colors and I can zoom in and I can pinpoint and get all this interaction will realistically change my understanding of the graph. In fact, it might be great, right? If I understand it in one context, maybe it's easier for me to also apply it to a different one. But a lot of people are just opening these pages compulsively, right? Or seeing it on their Twitter feed and just looking at it for 10 seconds. If that is the type of case that we're simulating, I'm not sure that this extra information is conveyed that well, especially if people are just taking parts of it or taking a picture and sending it to their friends and things like that. That part wouldn't come out as nicely. But again, maybe this is helping on that politician side, right? If you have hours to take decisions on this and you can run the simulations and you can look at these graphs multiple times, then I think it does get easier. It's definitely a better way to convey this information. Again, it's more about the audience that you have in front of you, I guess.
And I have a final question, which is maybe the most difficult one. And maybe some people can answer to that on the chat or think about that in small group, is the fact that we want to provide, I mean, we as a society, we want to provide and have access to raw data in a more transparent way. And so that's why all these organisms, the John Hopkins and everybody was doing by providing the data and putting the raw data. This informed the people, but maybe less accurately than a report saying next week it's likely that we have this, you know, in big letters. So, so maybe I don't know what will be your future field of research, but and if you're going this way or not. But there's really a big question of should we leave the data to the people, or with this problem of that it may be misunderstood, or should we give them, you know, the result already cooked?
This is a very hard question. So I'm going to do the following. I'm going to say that this is my opinion, and my co-authors might as well differ from mine. And I'll give you my take on this, which is we should give people the raw data. We should also give them the reports, because it's unlikely that a professional or even just a normal person will come back and run on all of these simulations on a daily basis. But mostly we should give people the tools to be able to understand the data they have in front of them. And this goes outside the COVID-19 pandemic, right? This is, although even within, right, when we think about the vaccine coming and the evidence supporting how well it works or whether people should take it or not and what are the dangers and the likes, it's incredibly important that we convey truthful information, but also that people understand it. Otherwise, we're going to get into a mess. And to some extent, we're already getting there. But this is the same for elections. It's the same when we think about big data. It's the same when we think about visualization. Some of these things are incredibly cool and definitely what we want in the future, but we want people to understand it. And there's an enormous gap that people have in terms of how well they can read data. So I think we should work on that.
Yeah, I think it's all related to where we started from visual literacy that Alberto Quero tried to improve in the whole society through his books, through his work, and to that sort of workshop. And I think it could be a sort of conclusion. I mean, somehow that we should all work to improve our own graphics so that people understand what we are saying, what we are doing. And I think your paper highlight the fact on how important this is. So since we are almost on time and that it's Friday and everybody has had some problems during this long year and even until today, so I'm proposing that we close the discussion with you right now, not without thanking you again for your presentation and for your participation on this workshop. This was really interesting. I think the problem there are really central, really. So thank you again, Chiara. And
thank you and happy holidays.